Hey guys, I'm Jim, WT1W, and you're watching FEP Labs Radio. Thanks for stopping by. Appreciate it. So today I want to do a follow-up to my last video. In the last video, we took a look at the MFJ 1703B RF safety switch. And this is a product sold by MFJ. They're going to be out of business in the next couple weeks, so take this all with a grain of salt. And this is sold as not just an antenna switch, but an antenna transceiver switch. So 2 radios, 2 antennas, and by switching back and forth, you can have radio 1 to antenna A or B, which at the same time swaps radio 2 to the opposite. So if I have 1 to A, then 2 is to B, and if I set 1 to B, then 2 is to A. So that's what this is sold as. There's not a lot of documentation on their website about it. It does say that it's rated for 300 watts. Now, I don't know if that's rated for 300 watts. I had several comments from some of y'all, and I don't disagree with you necessarily, that this seems pretty sketchy for something that can switch 300 watts between 2 radios and 2 antennas at the same time. So I guess the question is, if I have radio 1 hooked up to antenna A and radio 2 hooked up to antenna B, and I'm transmitting on radio 1, how much power might be getting into radio B through the antenna port while I'm transmitting on radio 1? So what we're going to do is hook this up to the Siglent SVA, and we're going to take a look at those numbers. Let's jump to what the test setup is going to look like and then look at some numbers. Okay, before we get into the gory details, I want to show you what kind of setup we've got. This is the Siglent SVA 1015X. I'm going to be using it in VNA mode today. And of course, here is the device under test, what we're talking about, the MFJ 1703B antenna transceiver safety switch. So that's how we're going to roll with it. Stick around and let's take a look at some numbers. Okay, so we've got our test all set up here, and I've already pre-calibrated the VNA, so there's nothing we have to fool with calibration. And what we're going to be doing here is an S21 log mag measurement. And log mag stands for logarithmic magnitude. So we're not doing a straight linear scale like watts are. We're doing, our scale will be in dB, which is a logarithmic scale, log 10, as a matter of fact. So this is in the connected mode of the switch. This is similar to the radio is connected to the antenna and the other stuff is out of the circuit. So this is what we see. We have no attenuation here at all because we're connected to it. All right. So I'm connected from radio 1 to antenna A on the 1703B switch, the MFJ switch we showed in the last video and the one we're talking about in this video. And we're going to switch it over to the other setting. So when I do that, what you're going to see here, and I'm going to have to auto scale it because this is going to kill the scale when I switch it. And now you'll notice, let me scale it for us. There we go. And now what you'll notice, if you look up here in the upper right-hand corner of our window where the mouse is jumping around at, this is the isolation or the attenuation that we're getting between A and B. So our signal is now on the other port from where we are. We're looking at the disconnected port. So instead of 1 to A, like I previously was, now we're on 1 to B. And as you can see here, this is pretty frequency dependent. So down here at the bottom, and these green diamonds correlate with our table up here, so you can look at it either way. Down here is 3.5 megahertz, and we're showing minus 46 dB of attenuation. So right now I'm going to tell you, here's the thing. And I could have missed something here, but I don't think so. This switch is supposedly rated for 300 watts, right? 300 watts, 100 watts is 50 dB. So 300 watts should be about 55 dB if my mathing in my head is right. And if it's not, I'll put the correct number over there, what it is for 300 watts correlated to dBm. But I'm not seeing anywhere near 55 dBm on this. So technically what I'm seeing is even at 3.5 megahertz, this is not really 100 watts or 100 equivalent to 100 watts of isolation, which should be 50 dB. 50 dB would be 100 watts, and we're not seeing that at all on this bad boy. And then, of course, as we go up in frequency, if you look up here, as we go up in frequency, the isolation we're seeing between the A and the B port on this thing is getting worse. So I don't know if I have a bad one. This unit is a couple, 3, 4 years old. I bought it back when I first got started in ham. I had a 991 and a 7300. And as I mentioned in the last video, I had them hooked up at the same time. Now, 2 caveats to that. I almost never had them on at the same time. Probably not that I remember, because I was worried about a situation like this. So take all this with a grain of salt, and take any of these switches with a grain of salt. Now, this particular measurement that I'm showing here, you can do with a Nano VNA. As far as I know, almost all the Nano VNAs should be able to do an S21 log mag measurement. That's kind of their thing. You should also be able to do this with the spectrum analyzer functionality. I just like to do this on the VNA side because it works out a little easier to set up. But I'm not seeing enough isolation here to put a 100-watt signal through this device and not affect the other radio. The other thing that I have heard, and this is anecdotal evidence, okay? I saw another video by W2AEW where he was checking a alpha delta switch, and he showed the isolation on the alpha delta switch, which was tremendous. And you should go check out his video, W2AEW, Alan Wolke, or Wolke, I don't know how you say his last name, W-O-L-K-E. Alan's a pretty smart guy, smarter than me. And he referred to a discussion he had had with Rob Sherwood of Sherwood Radio Reports, that guy. And Rob had indicated to him that almost all radios can accept at least 20 dB into the antenna input. So if that evidence is absolutely true, and we have minus 46 dB or 46 dB of isolation here, then that would be 66 dB, which is well over 300 watts. But that is not anything I've read anywhere that I could cite a source. That is a guy on YouTube was quoting another guy who does a lot of serious high-end radio testing stuff and knows way more than I do by far. So your mileage may vary. In any case, you can see here that as we go from the 80-meter band on up to the 10-meter band, and I skipped a couple bands because I didn't have enough markers for every one of them, but you can see that that isolation drops, gets less. So at 10 meters, we're only showing 27 dB of isolation between the A and the B port. And assuming that Rob Sherwood is 100% correct and that Alan Wolke quoted him directly, and that's correct also, even if my other radio could accept 20 dB of input, that means that I still, at 100 watts, am pumping more dB into that radio than it can handle, because that would be 47 dB of isolation. And if you remember, 100 watts is 50 dBm. So anything more than 100 watts, you are just flirting with disaster. When I was using this switch, as I said, I'm 99% sure I never had both radios on at the same time. There would have been no reason for me to do that. I can only use one at a time. And I just used it to switch radios and antennas back and forth. So whichever one I wasn't using, the 7300 or the 991A, was off, and that's how I switched it. And I never had a problem. I've long since sold both of those radios. Carlos Felix has my exact 7300 by way of a different guy. And I don't remember where I sold the 991A to, but both radios are working fine. I never smoked anything. So your mileage may vary. Take all the manufacturer's specs with a grain of salt, and if you can test it yourself, I'd highly recommend you test this kind of stuff yourself before you trust, you know, a $50 or $100 switch to a $1,000 or $2,000 or $3,000 HF radio. Guys, that's all I'm going to have in this video. If you would, make sure and give me a thumbs up. Subscribe to the channel. It's in the dingleberry below. if you're not already subscribed, and make sure that you click the bell so you get notified whenever I post any new content. 73, y'all have a great day.